Do record what we're doing here. So hopefully that recording works, and if it doesn't, I'm going to back it up with a recording on my computer. So I'm going to do that really quick too. I can find my recorder here. Where did it go? Where did it go? There it is. All right, so we have two recordings going on, and hopefully they'll both do well, and we won't have to. I did a recorded class last semester where the system broke down about, I'd say, once a week or once every 2 weeks. It was really annoying because the students wouldn't get their video, and I would have to do another video. We're hoping this won't be the case here. And I'm not sure about broken bow, so I'm going to go check something really quick. Bear with me. I want to see if I do have any students there. Whoops, it's not working for me. This first day, we're not going to do a whole lot of stuff, so we don't have to worry about falling behind anything. Okay, so engineering 1020 here in North Platte, we're supposed to have, we have 3 students on my list here in North Platte, but one of them I know is actually in Cook. So is that you, William Smith in Cook?
Yeah.
You go by William?
That's me. Will.
Will, okay. And then I've got 2 others signed up for North Platte, but I know that one of them is not also North Platte because Jesse Sandos, you're in Luke County, right?
Yeah, that's correct.
So they've misplaced both of you, it turns out. And I'm supposed to have 2 students in Broken Bow, but I don't know if I don't know if they'll be here during the class or not. They might just be doing they might just be watching the video later on their own to do the class on their own. And we'll find that out, I suppose. All right, so Zoom, where are we on Zoom here? Where's Zoom? Here we go. So the first thing we're going to do here is I'm going to share my screen with you, and we're going to get into Blackboard. I'm going to open up the Blackboard site for you. There's not too much on Blackboard at the moment, but it will grow as we go through the class. Let's see, I want that's Finder, Whiteboard, desktop one. I guess. That's what I'm going to share. I guess that's what I'm going to share. Okay, so are you guys seeing my computer right now? My computer screen?
Yeah.
Yeah.
Okay. So let's go to, now have any of you been on the Blackboard yet? For any other class? To get to Blackboard for,
Yeah.
go to blackboard.com. And it's inevitable the Blackboard will break down at some point during this semester. And I apologize ahead of time. I don't have anything to do with keeping Blackboard up on its feet, but it almost always breaks. It's not my favorite program in the world to use. We are going to be doing programming and problem solving, which you can see here on my computer is not currently available, but I'm going to make it available for you. Which we're going to do here. Somewhere. There it is. So you should be able to sign in on Blackboard and start to see what I'm seeing here, and you should do that. There's a couple of things that I have not updated on Blackboard yet because I've been working hard to try to get this class set up in the right classroom and everything else. One of them is the syllabus, but we'll look at it anyway just to give you an idea of what's going to go on in this class. It's last year's syllabus, but it'll give us enough information to be going on with. I will update it for you and we can look at it again later. Last year I taught this class as an online class, and I've been doing that for a few years, and it worked out fairly well at first, but as I went on through the years teaching it online, I found that a lot of students were not understanding some really key concepts at the very beginning of the class in particular, and it was really affecting them throughout the class. And then I just had a lot of students that just didn't do the work on time and got behind a lot, so I decided to go back to an in-class kind of format. But I still wanted to reach out to the students in the high schools who are interested in going into science and engineering and other things like this, because programming is very important in the sciences and engineering today. So that's why I offer this class as a podcast course or as a video course. If you can't make the Wednesday afternoon course, you just watch the video and then you work on these things on your own. The videos will be posted on YouTube, and I'll show you where that's at later. The basic idea of this course is that it's a 3 credit hour course, which means we're supposed to meet for 3 hours each week, and you should have probably 3 to 5 hours of homework each week, and we will probably be in that range somewhere. Some weeks we'll have more homework, some weeks we'll have less, some weeks we'll meet longer than others, and some will meet a little bit less than others. We'll never go over the 3 hours, but we will sometimes meet less if we don't have any questions and everything's going well. If you need to get a hold of me, the best thing to do is to use my email. You can also call me. My phone number here is 308-221-6434. But if I'm not in my office, it will go to my email. Goodness. You'll have to excuse me. I'm not feeling very well today. I might either have allergies or a really bad cold, but I'm feeling quite terrible. So I'm not grumpy or anything. I just don't feel good. The semester this year begins on the 11th, actually, and ends on the 5th. And that's because it's a leap year. We have that extra day in there in February. And the last day to drop this course, if you don't want to receive a bad grade because you've missed classes or whatever, is the 22nd of April. But before you ever drop a class of mine, I would really like it if you would come to me as early as possible in the semester when you start to think you're struggling, or you start to feel like something's not working out very well in the class. Come and talk to me and we'll figure something out. I can help you out. I can guide you through tough things and tough times in the course. I'm not a teacher that didn't have tough times myself as a student. I had a lot of tough times as a student. I struggled a lot in a lot of courses, and I had help from good teachers. And I am more than happy to offer that to you. So please contact me for any trouble that you might have. Unless it's some kind of personal issue you have with me, then you should probably talk to my boss, and I'll give you her number later if you need it. I will be in my office every day from, these are central times, not every day, but I'll be in there Mondays and Fridays in the mornings from probably about 8:30 or so, 8:30 or 9 until about 11, Mondays and Fridays. And then on Tuesdays, I will be available at 11 o'clock, after 11 o'clock in my office for an hour or so. The other days of the week, I'm pretty busy. Wednesday and Thursday, I'm pretty busy. But you can always call or send me an email, and I try to check my emails throughout the day, even into the evening, so that I can help my students out. This course is a computer programming course for students who have little or no experience with computer programming. There are no prerequisites. We do like you to have a little bit of math background, somewhere around the college algebra level, a little bit less, a little bit more is fine. But what we're going to do is we're going to teach you the basics of computing. We're going to teach you the basics of computer structure and computer design, actually, today a little bit. And we're going to teach you the fundamentals of computing, of problem solving using computers. And this is an essential skill for almost anybody in the science, math, engineering technology fields today. So it's extremely valuable. For the course materials, you will need to have access to Blackboard, so make sure that you've been able to get into that, you've got your password and everything. If you don't have that password, go ahead and call the college and they will send you the right person for that. Or send an email to the college and they will send you the right person. You can even send an email to me and I will send you to the right person. You'll need to have access to a computer, preferably your own computer. It should be a laptop or a desktop computer, a tablet computer, or a phone. Just does not have the computing power to run MATLAB. MATLAB is a very powerful, very big program. So you'll have to use a computer. And if you're anywhere near North Platte, you can use our computers on campus or any of our other campuses. You can use our computers, but you would have to tell me beforehand so that I can get the program loaded onto those computers. But it's really difficult to load it onto computers at our outlying schools. It's possible, it's just difficult. So it's best to have your own computer. And previously I made this part optional, the student version of MATLAB. We do have a text for this class, but we're not going to use this text. I've decided to move to a different text that I think is more updated. Actually, we're going to use a couple of different texts, and they are free for you, so you won't have to buy them. I'll show you about those later. But I've made the student version of MATLAB optional in the past, but now it has to be required because I was loaning out licenses for MATLAB in the past and discovered last year that that's not allowed under my license. So I was breaking the law a little bit there, a little ignorant of the law. But anyway, so you have to buy your own student version of MATLAB, and that can be purchased at mathworks.com. I'll show you that later a little bit too. Course requirements, we will have some of these elements, others we won't. When it was an online class, I had online discussions with my students. We will not be doing that. I will be expecting you to view the videos and complete the work that we do in class every day and turn it in. So every day in class, we will be doing some work in MATLAB. You will have your computers on and you will be doing work in MATLAB. And when you're done with that every day, you will save your work and you will email it to me. And that will be your participation score for this course. And I don't expect your work to be perfect, and I don't expect you to get everything right or understand everything the first time around. But I do expect you to do all that work in class every time that we meet. Of course, if you're not in class and you're watching this video at another time, I still expect you to watch the video and go through that work that we're doing each day and turn that into me as soon as you're done with it. For those of you watching the video, I know that some of you will watch the video the same day, some will watch it the next day or over a couple of days, and that's fine. Just please try to get it to me by maybe the end of the week so that you have time to get your homework done before the next class. We want to keep on task. We don't want to get too far behind. So the discussions will be replaced with an in-class assignment essentially every week. The shared document that we have here is going to be a part of this class again. I'm still working on how it's going to be a part of this class in this format of class. But the shared document, and I will show you this later also, is essentially an online Google document, Google Docs page, where you will be putting down little tips and tricks and things that you learn about shortcuts and things in MATLAB. If you learn something new in a particular day, you need to put that in there. And you need to be looking for things to learn that are new, because you're going to have to do this every week. You're going to have to make at least one entry in this tips and tricks document, this shared document every week. It's an extremely useful document because as you're going through MATLAB, you will learn things, and it makes your work a lot easier, faster, more efficient, simpler, whatever. And you want to share that, and you want to know what other people have found out as well. The only downside to this is if somebody beats you to a tip or a trick at a particular time, you can't use that one. So you have to read through the document to find out if your particular entry for that week has been used, and I'll show you how that works here in a bit. Then the programming assignments are the biggest portion of this course. The program assignments we will do every week, and they will be graded for completion, essentially 50% for doing the work and having some kind of work done for every problem. You will get essentially 50% of the score for that. Then, and before that, it was for viewing the videos as well. But for the completion of these things, 50% will include just getting in there and having some kind of a program, even if it's not working so well, on every single problem. Functionality will be 30%. So how well does it work? If it works well, the 30% is where that score is put. And then 20% of it will be style of programming. And at the beginning of the class, I'm going to be a little bit more lenient. And towards the end of the class, I'm going to start taking off more points for style. And we will learn about style of programming. It's very important to keep your programming clean, to keep it organized, to have lots of comments, lots of notes, take lots of notes while you're programming so that people can read your programming and know what it's doing without having to figure it out. And also creativity and conciseness and other things like this all fall into that style part. And if you have functionality that's not so good and style that's really good, I may even offer a few extra credit points to bring your score up in that way. A program that doesn't work but has really good style can be fixed, whereas a program that works well but has terrible style cannot be fixed or improved because it's difficult to read, difficult to understand. And then there will be a final programming project, and that will be also graded in a very similar way. Functionality will be 50% for that project. Incorporation of programming knowledge will be 30%, and style will be 20%. And the grading for the class, 20% of it will be I talk up here, I don't talk up here about quizzes, but essentially your quizzes are going to be replaced by the discussions, or in our case, the participation in the course that we do every week, and also in the shared document. That will be 20% of the course will just be between those two things. Actually, 20% of the course is just showing up to class and doing work. The shared document already has 10%. And then the assignments are worth 50%. They're a huge part of the class. The project is also a big part of the class at 20%, and that can affect a lot of things. So you will have a couple of weeks, hopefully at the end of the class, to work on that and to really hammer that out. Making up assignments. The assignments will be due. They'll be due in class a week after we meet and give you the assignment. I'll give you one assignment per week. And if we start getting, start doing really well, I might hand out a couple of assignments ahead of time if people want to work ahead. At this point, I'm only working on one assignment every week, so we're kind of building this class as we go. I'm not sure how it's going to go because I'm not sure how many problems to give you. Doing an online class is a little bit different than an in-class kind of environment, so I'm kind of playing it by ear, but we will have that hammered out probably in the next couple of weeks and know how many is too many and what's just right. Family Education Rights and Privacy Act. It's just we're going to keep your information private. Students with disabilities, if you have a disability and you need some kind of accommodation for that disability, you do need to report that to the school. And if you just call, if you call the school or call the campus that you're closest to, and they will be able to point you in the right direction. On our campus, it's Chris Turner, and I have his number here. So that is that you do have to self-report, and that has to be medically allowed as well. What did I just do here? Cannot minimize Zoom. Okay. Anyway, okay, so we're back to here. Chain of resolution. If you do have any, beef with me as a teacher or any other issues that you don't want to come to me for, I would hope that you would be able to come to me for anything. But if you don't feel comfortable, that's fine. Just go to my direct supervisor, who is Sally Falcon. This is her email and phone number, and she can help you out there. You can also go to the vice president of the school, who's Jody Kamonic, but she will probably refer you to Sally Falcon. Does anybody have any questions about this this syllabus that is not quite ready for this semester, but is close enough?
No.
Okay, well now that we've got... Well, sorry, was there a question?
We'll need to buy a MATLAB, the program.
Yes, you will need to buy MATLAB, and I'll show you where I'll show you where to purchase that here in a minute. You will need to buy that. Are there any other questions? Okay.
Can you get that through the bookstore?
You cannot get it in the bookstore. I just discovered this year that they can order it for the bookstore, but that would take probably a fair amount of time. You can, if you want me to put some on order in the bookstore so that you can use a scholarship or some kind of something like that to purchase it, I can do that. I promise you they will mark it up, and it will be a significant markup, and it already costs like $100, so you don't want to necessarily mark it up anymore. But I will show you where to purchase it online as well. So if you want me to order in the bookstore, send me an email, tell me that you would like me to put it in the bookstore. I'll get that done, but you can download it for free for 30 days and get started on things with plenty of time to get it in the bookstore too. So, anything else? All right, well that is the syllabus for now, and when I get the syllabus updated with our new class meeting information that's all different than was going to be, and there's all this other information that has been thrown at me the past couple of days, then I will upload that new version of the syllabus with correct everything on it, and we'll be ready to go. For now, I'm going to take us back to the home page. The home page is really the only page in my class on Blackboard. I don't like to have lots and lots of pages. I think it's confusing and obnoxious. So I just like to go ahead and just have one page, and everything's on this one page you can see. We have a little folder here for weekly assignments. We have course videos where I will post the videos on YouTube that I record every day. Then we have this place down here where there are textbooks. I'm going to open up that right now. We're going to use a couple of different textbooks in this course. And the reason being is that MATLAB has been updated pretty significantly in the past couple of years. And the textbook that I was using was not updated. And so it was creating a lot of disconnect for students. They couldn't resolve what the textbook was telling them and what they needed to be doing on the computer very easily. So I decided to find another textbook, and I couldn't find one that I liked that was from a book company. So I started looking at free textbooks, and there are a few out there that are pretty good, but none of them were perfect. So I'm going to just try to use what I can from every textbook, and we'll just go from there. In the end, the textbook is useful, but the most useful thing is the internet when you're doing programming of any kind. If you want to learn how to do something while you're programming, search for it on Google. Google is your best friend. YouTube is also a very good resource for learning how to program. So I would recommend that you learn to search in Google very well and learn to use YouTube very well as you are learning to program. But these textbooks, you just have to click on them and it will open it up for you. And it's a PDF document, so you can download it and print it if you want. And it's perfectly legal to do so. You can see that this textbook has 113 pages, which is quite a bit smaller than my last textbook, which came in at 617 pages or something like that. And that's why I'm using a couple of different ones to cover a lot of different materials. Table of contents here on page 4 shows us how we're kind of going to go through MATLAB, go through some basics of programming at the beginning, and then the user interface for MATLAB, which is essentially the windows that you're going to be working in. And then they go on to actual programming. And we'll cover some of that stuff today, if we get around to it. The other textbooks are similar, if not exactly the same, very similar. Some of them have some topics in them that are kind of scary if you've not been into calculus, and we will skip those topics. My voice is starting to give out because of my sickness here, so you may hear a lot of pauses at this end. I might even go get a drink. Anyway, the course videos, I didn't take that part, but the course videos will just take you to a YouTube channel that will have all the course videos listed here that I record. So that's pretty simple. Software and applications. So this is where you're going to buy the student edition of MATLAB. You're going to click on this, and it will take you directly to the student edition of MATLAB. If you go ahead and buy now, The student edition of MATLAB for student use is 99 bucks. And that's the only thing you need. You don't need to get any of these other options, these add-ons. This is for very, very complex computing, and we're not going to use any of them. Just get MATLAB and Simulink Student Suite, add that to your products, and you're good to go. Well, actually, it adds all those anyway. Well, it adds many of those anyway. It adds a bunch of them for free. That's pretty nice. We're not going to use many of them anyway. We won't use, I don't think we'll use any of them actually. We're just going to learn the basics of MATLAB, and that's all you need. Then you go ahead and proceed to check out, and you can pay for it with a credit card, or I think you can even use PayPal. However, if you don't want to pay for this now, you can get it a trial version for free. Let me see if this shows us how we can pay. So you can use Visa, MasterCard, American Express. I guess that's the only ones you can use. So Visa, MasterCard, American Express. And of course, if you do need that through a bookstore, just tell me and I will go ahead and order that through the bookstore as well. It'll probably cost around $120, $130 maybe from the bookstore. Okay, so that's the software you'll need to buy, and that's the only thing you actually need to buy. If you click on the MATLAB user, oh, they must have changed it. The MATLAB user community is essentially going to be found at mathworks.com, so we just go to MathWorks, and I'll update this link here in a minute. No, it doesn't like that. If you go to www.mathworks.com. Oh, why is it changed? MathWorks. If you type in the wrong address, it doesn't know what to do, apparently. www.mathworks. There we go. It takes you to the MathWorks website, and then you can go to the community here. And in this community, you can ask questions, you can look at what people are doing in MATLAB, you can download programs, you can look at blogs. These blogs are often very helpful. But they also have, and here's the trial software you can get for free down here on the left. But they also have videos. If you go to, if you go back here to, go to training. Let's see, online. No, that's not the training. Support.
We can't see your screen. I can't anyway.
What's that?
I can't see your screen.
You can't see my screen? Can anybody else not see my screen?
Yeah.
It must have switched it without telling me. It's sharing the screen. It says it's sharing the screen.
It switched over to you when it was on the computer screen.
Is that better?
There you go. Yeah.
Yeah, tell me that as soon as that happens. Because that just kind of happens every while sometimes, apparently. And if it does, tell me right away so I can fix it, so I can go back and fix it. All right, so let's see, where were we? At MathWorks, we can go to tutorials. You can watch videos under support. Learning MathWorks Basics is essentially going to take you to a YouTube video. It comes through. Right, so you can learn the basics of MATLAB under the support button. And you can search the videos and look at webinars. You can do all kinds of things on MathWorks. But YouTube also has a MathWorks channel. So you can go there, you can go to YouTube and search for MathWorks. And if you do that, you'll find just tons and tons of videos. We go to, just search MATLAB. There's a MATLAB channel. And you can read about MATLAB, and you can watch video lectures about MATLAB, and you can watch people doing things, specific things with MATLAB. And let's say that I want to learn how to do a for loop in MATLAB, which is something we'll learn later on in this class. I want to go to for loop MATLAB in YouTube, and we can watch a for loop tutorial, 13 minutes long. And you may notice that as you get into some of these tutorials that their screen is not going to necessarily exactly match yours. Maybe they're using an older version of MATLAB, and that can happen. So you might want to switch around until you find one that's using a version of MATLAB that you're familiar with, that you're seeing. The versions are not terribly different, but they're different enough that it can be confusing. So those are the videos that we have available, the different resources we have available for learning this semester. If we go into our weekly assignments, we'll see some links here. We have our week 1 assignment, and then we have our MATLAB functions tips and tricks document on Google Docs. I'm going to put that one first, actually. Let's go to that one first, and let's see what my students have done in the past. Obviously, this one's kind of unupdated in the title, at least, but what I've got is, at the beginning, I've got an example where you leave some space and you put your name, and then you explain your shortcut. So, for example, the shortcut that I gave as an example was to, if you want to run your code that's in an M file, hit the F5 key. And you'll know what that means as we learn more things. Then I had another student that did the tips sine, cosine, and tangent functions use radian measures instead of degree measures. So if you're going to use those functions, don't put numbers into the sine, cosine, or tangent. Using degrees, use radians, and we'll learn more about that later too. Robert Edwards, a student of mine, said, if you put a semicolon after your input, MATLAB will not show that input. It won't print it to the screen. Extremely useful tip. And it just goes on and on and on. There's more and more tips as we go down here. And you can get on here and start looking at these tips that have been given by students in the past, and that's perfectly fine. But before too long, I'm going to put a new document up. So it's not a bad idea to read through these tips and learn about them at the beginning of the class. You could even put them into our document when we start. But I will make a new document probably later today, along with our weekly assignment, and post along with our weekly assignment, so that you can start working on that. You should do one of those a week, one entry a week, and it should be unique. You should have a new entry that nobody's written about. Anybody have any questions about that shared document we're going to be working on this semester? Okay. So now let's go to our first assignment, which I think I mentioned is not quite complete, but it will be complete before probably the end of today. It will open up like this. You can save, and I'll give you some instructions here. Tests can be saved and resumed, so you're not time restricted. It allows you to go in and try again and again and again. And then here it says it's due on January 17th, 2014, which is not exactly true. I will give it a due date of whatever. Well, maybe the 17th is Tuesday. No, 17th is a Sunday. So I will give it a due date of probably Tuesday night, the 19th, probably like 11 p.m. or something like that. But you just go ahead and press begin when you're ready to go, and you can get into the assignment and see what it's about. If you've never used Blackboard, Blackboard has lots of different ways you can submit assignments, and for almost every problem in this class, you will have what is called a file upload assignment, so that you will be working on your computer and saving things to files, and then you will upload those files to me. Upload those files in here, and then you will send them to me through Blackboard. And for example, this first question says, I want you to watch the video creating a simple script in MATLAB. So you click on that link and it takes you to YouTube to watch the video. And then after you've watched the video, you'll do the assignment and whatever it says here for that part of the question. It says, learn how to say programming commands to a file, create an M file with the commands used in the video, and upload it here with your file name, with the file name, yourname.m. Whenever I tell you to put something in yourname.m, that means write out your name. And don't put any spaces in between your name. If your name is Mike Davis, put in Mike Davis. Or you can put Davis Mike or whatever. But I would like your name in the title of this file, .m. It has to have a .m at the end. That is the extension of files, one of the extensions of files used in MATLAB. And it's not a very big file. It won't suck up memory or time or anything like that. It's just a text file that has lines that you have written out in MATLAB code. The second problem has several problems involved in it. It has 7 problems total that you're going to put into a file. I've only put in 6 so far, but when you're ready to put in a file that, you'll browse your computer and you'll choose that file from wherever you saved it to, and then it will upload it to Blackboard. And you can see over here that there are 70 points for this problem. Question 1 has 10 points. It only has one question, really. One thing that you can do, but this one has 70 points. Each question will be worth 10 points, and each question will be graded according to the grading that I showed you in the syllabus, which looks kind of like this. We have completion, program functionality, and style and cleanliness. And if you're unsatisfactory, you might get a 7 or less in completion. If you're exemplary, you'll get a 35. And somewhere in between, you know, you might get somewhere in between. Program functionality has the same kind of scale, and so does style cleanliness has the same kind of scale. And that's how I will be giving you feedback as I enter in scores here. I will also be able to write to you some feedback. I'll type in some feedback. Maybe I'll have some ideas for you, and you can check there. But I also will probably send your files back to you with some comments in the files themselves. So something else to look for. You can see here in problem 1 that it says predict the outcome of the following MATLAB commands. 1, 2, 3, 4, 5, 6, 7, 8 different commands. You have to put all these into MATLAB, so you're going to get 8 different things going on just for that one problem. But you also have to predict them because it says to predict the outcome. So you're going to write that. It says right here you're going to predict them by writing them in your M file as a comment, and then it'll tell you how to comment. To comment, type a % sign before the text on each line. That's kind of a tip or a trick or a shortcut or something that you might put in our shared document. It probably doesn't make much sense to you now, but I promise when we get started in MATLAB, it'll make more sense. And that's how the assignments will go. This assignment has essentially 2 questions at this point, but it will end up with, I think, 4 total, maybe 5. I think I've got 4 here right now. So I think it'll end up with 4 questions that are all kind of similar to the one that you saw in question 2, where you will have some tasks to do, some things to save in a file, to enter into a file, and then you will have to upload that into the question to submit it to me. When you're done, it's a good idea to save your answers. Even if you're not quite done with the assignment, it's a good idea to just save answers if you've entered anything in, so that you don't have to go back and do it again if your computer crashes or the internet crashes or whatever. And then save and submit button will actually submit it to me. So, but you can also submit multiple times. So if you think you've got it right, but then you realize later you didn't get it right, go ahead and submit it again. And I will should be able to distinguish that. I'm trying to remember how that works, but anyway, yeah, it will. So, I'm sorry that my voice sounds so boring and that it's so flat, this discussion or lecture as it may be, that I am just falling apart here. I think I'm going to pass out pretty soon. Whew, okay, so moving on. I'll try to keep it together for just enough time to get us started in MATLAB. So once you have downloaded MATLAB and initialized it on your computer, you've got it up and running, this is kind of what it's going to look like. There are different ways to arrange these different panes in this window. There is this pane up here, which is the folder pane or the path pane, they call it sometimes. This over here is your workspace pane, like the panes in a window. This is your command window pane. But you could have other panes in here, and the way that you could change that is you go up here to this button up here, this layout button, and you could just change it to a 3-column so that you have your current folders over here and your workspace over here and your commands in the middle. But you could also have just the command window, for example. And you could go back to the default, which is this one. I actually like to add a pane to my window usually over here that includes plots, things that I'm making pictures of. But you can also go up here to view any plots that you've got going. And this new design that they've got with these tabs up here at the top and all these different buttons obviously is following Microsoft Office's design. And they do that on purpose because they know most people have used Microsoft Office and they're comfortable with it, and so they want to make them comfortable here. As soon as you open up MATLAB for the first time, you'll see right at the top, new to MATLAB, see resources for getting started. Not a bad idea to click on that, and we probably will before the end of the day, but we won't do it at the moment. We're just going to essentially go from the top down and look at what we've got going here in our window. At the very top, this is a Mac, so I've got my close and reduce and expand buttons up on the left. For your Windows computers, they will be up on the right. For a Mac and Windows beyond that, it's pretty much the same except for the color schemes, I think, are different. I think for Windows, these aren't blue up here, but they might be. I can't remember. It's been a long time since I've used a Windows computer with MATLAB. But most of the differences are going to be just aesthetic differences. You've got this search bar up at the top where you can, if you're not talking using Zoom, you can search. And then you've also got a new shortcut button here, and you've got some save and some cut and some copy and paste and other things like that that you're used to seeing in things like Microsoft Word and Office and other Office documents. On the left here, just like in Office, you have a new script. Instead of a new document or a new spreadsheet or a new PowerPoint, it's a new script. And if I click on this, it's actually going to open a new pane right here in the main part of my window. So now this is called the editor pane, and this is where I'm actually going to build a program of some kind. The command window is where I tell MATLAB things to do. The script window is where I put together a bunch of things for MATLAB to do, and then I tell it to do all of those things at once. Or I tell it to do those things in some kind of succession. So this is kind of like a planning area right here, and this is where you're going to write all of your problems. This is where we're going to put all of your information. Right now, it's just called untitled, and so you might want to save it. And as you can see that the save button has come up here, and it's also come up over here. So if I press save, I've got untitled, and I'm going to go ahead and call my class, my file that I make in every class. I'm going to give it my name, so I'm going to call this one Jared, and you can use capitals if you want or not. I'm going to call it Jared Daily. And then without any spaces or anything, I'm going to put a number here. And the number is going to be, and you're going to do this every time we meet for class. The number is going to be today, the year for today, which is 16. And then the day of the month, no, sorry, the month, which is 01, and then the day. So it's going to go year, month, day. And the day today is the 13th, right? So 160113. And that's going to be the name of my file. Notice down here, the format for this file is a .m file. It's a MATLAB code file, and that's what we want to do for this particular file. So I'm going to go ahead and save that. And I now have my file for today's work. If you don't have MATLAB loaded into your computer today, don't worry about it. You can go back and watch the video and do your file later. We're not going to do a lot of work today, so it won't take you long to do that. And the homework's not that hard to do this week either, so you'll have plenty of time to do this. But this is now my file. Just like with any homework assignment or any file or any kind of thing that you do want to have some labels on it that tell people what it is. And in MATLAB files, when we put things in it that are not part of the code, they're not part of telling the computer what to do, they're just explanatory for whoever might be reading it, we call that commenting. And to comment, you need to put in a % as your first character on the computer, or first character on the line that you're in. You can see over here on the left that I'm in line 1, and MATLAB will number every line that you're in because you're going to need that later to find things in your code. And as you comment in this line, you could put in many, many % signs, and that's fine. You can put as many as you want, and it's going to show this line as comment code. Comment code, when you open it up, when you open up an M file in MATLAB, will always show up in this green color, unless you set it up differently so that it shows up in like purple or something, but I think the default color is green. And anything that you type after a percent sign on that line will be considered not part of the computer code, not part of the program, but just extra stuff, just explanatory stuff, commenting. So I might put my name on the first line, for example, Jared Daly. And I might do code for class on 1/13/16, just so that it's very clear what this is all about. And I can press enter right here and go to the next line. And then I can put some more commenting in. Maybe I say, this is all about the introduction. We're just barely learning about this. The interesting thing about this code, commenting, is if I write some code down here in my editor, for example, let's say I want to write 3 plus 4, 5, well, plus 5. MATLAB knows exactly what to do with that information. It knows that 3 is a number. It knows the plus sign is an operator that means add. And it knows that 5 is also a number, and it can add them together if I just type it in like that. So that's perfectly good MATLAB code. However, if I wanted to comment on this line to tell people what I did, you put in a percent sign on that same line, and it will turn the rest of the line into comment. So I just added 3 plus 5. Whoops, there we go, 3 plus 5. And it's pretty simple. Let's see. Just for those of you out there in the distance learning sections, we were just joined by a student here in North Platte who will always be about an hour late because he's in another class at the beginning of this class. They double booked some classes and we weren't supposed to, but they did anyway. But he will be joining us for this. And so anyway, we have 2 people out on distance learning, 1 person here in North Platte. We're supposed to have 1 other person here in North Platte that didn't show up. And then we have 2 people that will be watching this at a later time and doing the work on their own. So anyway, we are recording this. Let's move on with things. So this green code that comes, this green line that comes after the percent line, the percent sign, just adds commentary to your code. And the reason I'm showing you this before we really get started with anything else is because it is so important to add comments to your code. Reading code can be very difficult, especially as it gets more and more complex. When we start doing things like creating graphic user interfaces, changing images, making animations. As we start to do things like that, it gets very complicated, and it's not obvious when people look at what you've done in the code, what you're actually trying to do. It may not even be obvious to you after you've done it. So it's a very good idea for anything that is not really simple like this 3 plus 5. It's a really good idea to write a little explanation, maybe explain what a variable is. For example, if you choose y to equal 28, tell them that y is the height of the basketball player's jump in inches or something, so that it's very clear to the person reading the code what you're doing. And we'll get lots of experience seeing that as we move through the class. So that is the basic idea of the editor window in MATLAB, this window right here, kind of middle right. But you'll notice here on the left here that we have actually some things that showed up when I saved this file. What showed up was the file. When I saved the file, this is telling us that this computer knows what this file is and where it is. And it actually shows us up here the path that it takes to get there. It's under Users, Jared Daly, Documents, and under the MATLAB folder, if you follow this path through the computer, you will find this file now. It is also showing us that part of this file has not been saved. That's what this M little dash means, that it's kind of open and in progress. If I save it, it won't go away because it still doesn't know that I haven't done anything here yet. It doesn't know what I've done until I save it. So that will be there as long as I have the window open, the editor open. And in fact, when you transfer this file somewhere else, sometimes that little M with the little squiggly line goes with it. So don't worry about this file with the squiggly line at the end. It's not necessarily, not important necessarily. If you do lose this original file, you can click on this file and open it. Just erase that little squiggly at the end and you'll get the last saved file that you have. So it's kind of like a little backup, I suppose. But then if we go down to this workspace, you'll notice that there's nothing in there and I haven't done anything in the command window yet. So let's go to the command window and let's ask MATLAB to do something. Let's ask it to do this very simple thing, 3 plus 5. So if I just do 3 plus 5 and hit enter, notice that when I type down here, there's these little arrows. When you have these little arrows, that's when you know that MATLAB is taking what you've typed in and it's going to do it, whatever it is you ask it to do, as long as you ask it to do something it knows how to do. So I put in 3 plus 5, and you notice that it has this thing that says ants equals 8. Ants is, of course, short for answer, and equals 8. When a computer has to store a number of some kind, it usually gives it a label. It gives it a name. And if you don't give your answers a name in MATLAB, it will just give it the name answer. And so if I type in ANS into MATLAB right now and hit enter, it knows what ANS is. It knows what answer is. It is 8 because it was 3 plus 5. However, if I do 3 plus 4, which I will do right now, answer is now 7. If I type in answer, it is no longer 8, it is now 7. So MATLAB is always keeping that last answer that you didn't assign a name to in its memory. And that's exactly what this workspace is over here. This workspace is MATLAB's memory. It's all the things that it is remembering while you're working right now. So while I've been working right now, it's remembered answer. Now, you can assign things in MATLAB. So if I decide to assign a name to something, so if I say W equals 3 plus 5, the equals sign in MATLAB is essentially telling MATLAB that you're going to give W this value. You're assigning W this value. And W in MATLAB is called a variable because we can change it. So if W equals 3 plus 5, and I hit enter, it remembers that W is 8 and it puts W as 8 over here. Now if I type in answer again, answer is still 7. Because I didn't change what answer was because I assigned 3 plus 5 to be W. And I can assign as many things as I want to be 3 plus 5. I can call them Joe or Fred or Henry or whatever else. But there are some limitations. For example, I can't say 7 is equal to 5. If I do, I get a completely different thing. So if I put 7 equals 5 here, and I hit enters, it gives me an error. The expression to the left of the equal sign is not a valid target for an assignment. So a target is essentially a valid name. It has to be a name that MATLAB will accept. And obviously a math program is not going to accept numbers as an assignment name, because if you make 5 equal to 7, your math is going to be really screwy. So it doesn't allow that, but it will allow names. Anything that starts with a letter is fair game. So you can put Joe 456IV or something like that equals 9. And it's fine with that. However, if you start with a number, it will not be fine with it. Also, it doesn't like periods, it doesn't like dashes. There's a bunch of things it doesn't like. So if you put in Joe-909, for example, we'll let that equal, we've got a couple of variables over here, so I'm going to show you something MATLAB can do. I'm going to let it equal answer plus W. Answer plus W, because MATLAB knows what answer is and knows what W is. But it doesn't like this. Why? Because the dash is not allowed. Now here's another trick kind of thing for you. I want to redo that previous line. I want to do that line again, but I want to fix it so it doesn't have a dash in it. If I go to my keyboard and press the up arrow, it actually gives me all the commands I've done for the past few minutes. And I can choose that line, hit enter, whoops, it does the same thing again. I can choose that line and then I can scroll over into my Joe and I can put an underscore, for example. Underscores, MATLAB does like. So if I put that in there, it adds together answer and W, 7 plus 8, which is 15, and it assigns 15 to Joe underscore 09. And that's perfectly fine. So that is the command window. When you type something into the command window, MATLAB will either recognize it as something it can do, or it will recognize it as something it cannot do. And then it will go and do it or not do it accordingly. Pretty simple. The workspace gives you the opportunity to look at things that you have saved in the computer that the computer knows about, so that you can use them in your programming. And you can use them up here or down here, as long as they're showing up here when you're doing this stuff. So how do we use an end file down here in this window? Well, this end file has a name, Jared Daly 160113. If I put in that name, Jared Daly 16, oops, I'm a terrible typist when I'm not feeling well. 13, even when I'm feeling well, I'm not that great. So that's 160113. If I just type that in here, as long as that folder, as long as that file shows up in my current folder, in my directory over here, as long as that's right there in that current folder, and everything that is inside of here is in the workspace. So if I'm using answer up here and it's not down here, if I'm using W up here and it's not down here, then this won't work. But if it's all hunky-dory, I can plug it in and it will do whatever is in this file. It added 3 plus 5. Answer equals 8. If you want to open files, you can go up here to open, or you can click this button and it'll take you up one level and you can go to MATLAB and look for files that you've got. Or you can go ahead and open a file here and it will open up in a separate window. There's lots of different ways to look for files. You can click up here and it'll take you back in your directories. There's lots of different ways to navigate through MATLAB to find files. I would recommend storing your files all in one place and maybe making some folders. So click here and click a new folder and make a folder that's week 1 maybe. So that all stuff for week 1 is in one place. And once you've got it all in one place, you're good to go. Right? It's not a bad thing, but then you have to open up week 1 to use it. So another thing that you can do is, as you're writing code, for example, if you're in your editor window, you can actually run it using this button, the run button. So if I click run here, it will actually run the Jared Daly file again. And it did it, but it did so fast you didn't really see it. So it did it again. See, this was the first time. I'm going to open up my command window a little bit. This was the first time I ran that file. This was the time that I pushed the run button. A very simple file like that is extremely easy for MATLAB to run, so it just happens instantaneously, almost very, very quickly. Or you can use run in advance or run a section and step through the problems, a little bit at a time or whatever it is. You can also use these buttons up here to kind of format your programming in your editor window. You can indent and you can comment and do all kinds of things up there. It's useful too. And you can also run and time your file. If I do that right now, then I ran that file and it took it took 0.000 seconds. It can't even time this file. It's taking so little time. The CPU doesn't run fast enough. So it's running so fast, there's just no time. But that's very useful when you're running a program that's very big and you want to know how long it's taking. Give you an idea. Sometimes they can take hours. Not from this class, hopefully. Okay, another very important feature here is this feature right here called breakpoints. And this is the last thing I want to point out to you. If I hit a breakpoint in here, I can set or clear breakpoints. I can clear all breakpoints. I can enable or disable breakpoints on the current lines. I can set conditions or whatever else. What are breakpoints? Well, if I go into my file here and I hit break, if I just write break, MATLAB knows to stop running. So it'll just stop at that point. If I put a time after the break, it will stop for a certain amount of time. If I do stop break for 5, for example, it'll break for 5 seconds. And usually when I put in a breakpoint, I actually put in some spaces so that I can see where it is very easily. Whenever you type in a word that is used by MATLAB, it will come up blue. And those blue words are not allowed to be used as variables. So you cannot use break. You cannot assign break to equal something, or you shouldn't. You can, but you really shouldn't because MATLAB uses them all the time. But then if I put 6 minus 8, for example, after the break, and then I go ahead and save this, you got to save it before you run it, and then you have to make sure that your cursor is inside the file before you run it, unless you want to type it into your command window. So if I run this, it's got a problem here. And the problem is in line 7, column 7. Now I thought this might happen because I couldn't remember exactly how to do this. But it tells me where it is. It's in line 7, column 7. 1, 2, 3, 4, 5, 6, 7. That's right there. So it's invalid. It might be invalid MATLAB context, they say. If you want to know how to use something in MATLAB, it's really easy. Go like this. Go into your command window, go help, and then type in the thing that you want to learn how to use. And it will tell you how to do it. And usually it gives you quite a few things here. Oh, so break, it says break is not defined outside of for or while loop. So that's not, we don't want to do break inside of here. We want to actually use a different thing. And that's a good thing to know because I've forgotten that it's actually called something different outside of a loop. It's called pause. So let's put in pause 5 and save. And let's run this again and see what happens. Well, it doesn't like that either, so I'm going to go again to help. And you will use this a lot, help pause. So here it says I have to put it in parentheses. The 5 has to be in parentheses. So I come back up here and I'll delete that space. I'll put some parentheses down. And this is very common with MATLAB code is that you have to use parentheses. And then I'm going to save it again. And I'm going to tell it to run again and see what happens. So the answer is 8, and then it's pausing for 5 seconds. And then the answer is -2. It changes the answer after those 5 seconds. You will not use that so much in your homework as you will use just pause. If I put in just pause, it just stops until whoever's looking at your program hits a keyboard key or a mouse button. Okay, so if I do this, if I do save, and then I run it, it gives me the answer equals 8, and it'll just sit here until I hit enter. And I have to click into the command window first so that I have my cursor in there. Then if I hit enter in there, then it goes to the next section. The reason I'm showing you this idea of the pause, is I want you to put a pause in between each problem, at least each problem on your homework, so that I'm not getting everything all at once. So I can kind of click through your homework one problem at a time. Some problems will have parts A, B, and C to them. If a problem has parts A, B, and C, then I want you to do A, B, and C with pauses in between. And put a space in there. Having lots of white space in your code makes it very easy to read. And I can't say that enough. Put spaces in between things. Having spaces in your code makes it easy to read. Sometimes it makes sense to have 3 lines in a row without spaces because they're all related, but try to put as many spaces as possible to make it easy to read. Grouping and spacing is very important. And that is the last thing that I want to show you in MATLAB before we go watch a video. We're supposed to go until 3 o'clock, and it's 1:11. I'm going to take a little bit of a break, and I'm going to let you guys take a break. Maybe 5, what time is it? 1:11, so let's take a break for maybe 8 or 9 minutes, till about 1:20. I'm going to go get a drink and rest my voice. We'll be back and we'll watch a little bit of a video to learn about how computers do what they do. So I'll be back and I'll just let this run. I'll be back in a few minutes. Okay, Matthew, for you, do you have a computer at home you can put that on? Before you came, you talked about stuff that's on Blackboard. On Blackboard. And while you're in class, since you're doing the time, you can open up that on this computer. And then, so in the class, you can just use it right there, not have to break it. Okay, I'm back. What else did we talk about while you were? We're using free textbooks for this class that are available on Blackboard. We're doing, we'll have one assignment a week, but during class, you'll have to have MATLAB open and do all the activities with me that I do on my computer. So when I do them, you do them, so that you're getting experience using MATLAB, hands-on experience every day. And then when you're finished with that, you'll turn it in, and this will be the format of that file: your name, and then the year, the date, the month, and the day. .m. And when you're done with class that day, you'll just send that to me. Of course, today, not everybody has MATLAB accessible, so as soon as you get it loaded on your computer, just go back and watch this video and do this stuff again. You can see I haven't done much yet. This is my file. I've got some stuff up here, and some comments up here, and some comments here, and just 3 lines of code. But we will do a few more things here before we're done. So, are we all back? You guys back there in McCook and Luke County?
Yep.
Okay, so I want to start today off I want to watch a video and take a break from talking and coding for a little bit. And the video I want to watch, I hope I can find, because I forgot.
Is this class supposed to go till 2:30 or till 3? Because it says from 12 to 2:30.
Well, we can do 2:30. That's fine with me. It probably is 2:30. Yeah, 2:30. Scared you, didn't I? This is how I found this video. How computers work. And the one that I found was this great video from like 1960 something. See if we can find it here. I love watching old videos about how things work because you can learn a lot. Where's my video? You can learn a lot from how things were explained to people when they first started coming out. You know, computers were just becoming kind of known in the 60s. When my father was in college in the 1960s, he was in college for almost the entire decade of the 60s. They got their first computer at the university he was at, and they were one of the first universities to have a computer in the nation, to have an actual like electronic computer. And the computer took up the entire basement of the math building. And it's a big basement, I know, because I've been there. And it was very new in the early 60s. Computers were electric digital computers were very new. And so in this video, they're essentially giving us not only how computers work, but the history of computers throughout all time. And it's a long history. Computers have been around with mankind for thousands of years. And it's just this new type of computer that we use today, which we call the digital computer, that is the new one. So even though this seems a little bit cheesy at first, it's very informative and very useful for us, for those of us who want to make a computer do something for us, besides just writing papers and PowerPoints and surfing the internet. We want to program a computer to do something very specific. So we should understand it. That's what we're going to learn today. If you have any questions during this video, go ahead and yell out, stop the video or something, and I'll stop the video and answer questions. Otherwise, I will stop the video from time to time to make some comments. And this is about 16 minutes long. I think it's about 20 with all my comments or more. Go ahead and start. Is the volume okay there in McCook and Luke County?
I can't. I can't hear anything. I don't know.
Can't
Is
hear
it
anything?
talk? Is someone talk?
Okay, let me pause it really quick. I think I have to change my volume in here somehow. That's not right. Oh, here it is. Video, mute, share more. Audio options. No, that's not it. Where's my volume? Stop, don't want to stop sharing. I don't want to pause sharing. I want to stop the recording. Options, video settings. Oh, there we go. Okay, so apparently the input volume's all the way up. What I will do is just turn up my volume on my speakers, and hopefully that will help you out. If not, I will. If not, you'll just kind of have to watch it on your own. It's not part of the assignment or anything, so. And you can actually learn a lot just through watching it, but I will turn it up here. Get back to my video. I'm going to keep this out of here. This needs to go up here.
Are they superhuman machines that can solve any kind of problem? No, not any kind. Are they man-made monsters that perform mathematical miracles in millions of a second? No, nothing miraculous at all. More monsters. Are they electronic brains that can do man's thinking for him? They can do some of it, and be big and quick about it, too. Large computers can remember and keep tab on millions of bits of data, and fetch and use any of them at all.
I'm actually going to pause here. In my engineering courses, I often make social commentary because engineering has affected the human race so much in so many different ways. And this, of course, is the 60s. You can tell from everything about it that it's the 60s, or maybe 50s even. But you notice that they already have a lot of women in the pictures here. And if you go back into the 50s and the 40s, that was kind of where women started to get out into the workplace a little bit more, particularly during the 40s or World War II. And in the 50s, when women decided, hey, I can do these jobs because my mom did it during World War II, I can go out and get a job. And they started entering the workplace. And it's very interesting that in computers, the people that were running these computer centers, because they weren't just a computer, it was an entire building often, they loved having women run the computers. And it actually is a big part of kind of the social evolution of the sexes in the human race. Before the 1940s, the women were supposed to stay home, and they were supposed to clean the house, and they were supposed to make dinner and have it ready on the table for the husband when he came home, and he handed his newspaper and a pipe, and he'd sit in a chair, and he would smoke his pipe and read the newspaper, and then he'd come to dinner and be a perfect hot meal, and all these things. And they were responsible, essentially, by social norms for a lot of very particular tasks that had to be done in a very tight schedule and had to be. It was very important in our social structure in America that the women be the clean person and the orderly person at home so that the man can come home to this great place. And that was all very sexist and everything else, of course. But what they discovered, and they didn't really discover this until probably the 80s or the 90s, they didn't really realize why women were so good at this. But computers in the 60s had to be organized and very clean. The rooms that they worked in had to be very clean and very organized because essentially the entire room was the computer. And if it got disorganized, it didn't work. Everything from where things were stacked to where pencils were kept was kept very orderly. And women were perfect for that. Not only were they good at it, they enjoyed it because it was something that had been programmed into them for decades. And, excuse me, while this is not necessarily the social norm still today, it is still actually kind of part of the DNA of our race. It's not a race, of our species, because that part of that sexual selection, I guess, of the sexes went on for so long. And it turns out that even though not a lot of women go into computing, they should, but not a lot of women do. When they do go into it, they're quite good at it. There are a lot of women that still have this mind that has just kind of been passed down through the generations, and it is definitely a very Darwinian thing, where their minds are organized and tidy, and they live an organized and tidy lifestyle. We know that not all women are that way, and some men are that way. We know that's the case, but it's an interesting social commentary to notice how many women are in the computer world in the 50s and 60s. There's a lot of them. And they were the heart and soul of the computers, essentially. They got things organized, they got things running, and when things went wrong, they were able to fix them because of their order. And it was a great thing. Of course, we don't have people inside of the computer so much anymore. It's much more about organizing wires and everything else. But it's still very much about order. And the social part of this should not escape us. Engineering changed. Engineering allowed a lot of women to get into the workplace, into a high technical area at a very early time. And it's been one of the very few places where they could get into a high technical area at this time. Granted, they didn't get the pay that men did at that time, of course, and some of them still don't. But it was a huge step socially, I think, in not just America, in the world. So engineering affects a lot of social issues, and it's important to recognize that because it will continue to do so.
Are they electronic brains that can do man's thinking for him? They can do some of it and be big and quick about it too. Large computers can remember and keep tab on millions of bits of data and fetch and use any of them in a fraction of a moment. And computers operate faster than, well, how many human beings using desk calculators would you say? 100? 1,000? More than that? Yes, 500,000. Yet, as complicated as they might appear, digital computers are basically simple, a collection of ideas and principles that are not all difficult to understand, nor are they very new. Here is the first computer man ever used. It was the first digital computer. Indeed, the word digit comes from the Latin word for finger. Used in counting them, digits became numbers. To keep track of numbers or to count higher, man used stones. We still use the Latin word for stone, calculus, and the first calculating device may have looked like this. With it, you could count your sheep, your children, your prayers. In fact, the Anglo-Saxon word bead meant prayer. When man put up his counting beads like this, he grouped them like the digits of his hand, with the extra beads counting the number of fives. The abacus, used by all civilizations of antiquity, is still a widely used counting or accounting device. 350 years ago, a Scottish scholar, preacher, and mathematician named John Mathier invented the ivory calculation bones, as they were called. This is one of the original sets. They were used for multiplication. A few years later, the French genius Blaise Pascal invented and built the world's first mechanical adding machines. This is one of them, made in the 1640s. Pascal's achievement lay in the gear mechanism, which automatically took care of carryovers. For example, 6 plus 9 as the 1 carried over to the next place. Also in the early 1600s, an Englishman, William Oughtred, put together 2 logarithmic scales like these, and made the form of slide rule we use today, an indispensable 300-year-old tool. In every area of defense, science, engineering, manufacturing and business, progress depends on the availability of fast, accurate methods of calculation. They have enabled us to take giant steps forward in power, in control, in design, in processing, and in research. Our 7-lead boots are our calculating machines, and they come in many styles. In some, the action is entirely mechanical, using levers, linkages, gears, and ratchets to perform the calculating operations. The method used here is digital. That is, the machine works with digits, actual numbers. In this type of calculator or computer, the action is electromechanical. It makes use of servo motors, potentiometers, hands, friction drives, and similar devices. They are moved or set so that shaft positions, voltages, angle, length, and other physical quantities represent the numbers involved in the calculations. Since equivalents or analogs of numbers are used rather than numbers as such, these types of machines are called analog computers. In this type of computer, the action is entirely electronic and completely automatic. The working parts are transistors, vacuum tubes, magnetic devices, and other electronic components. The machine works with actual numbers, and is therefore a digital computer. This film is concerned with this type of computer.
So this is an important definition for us as engineers, scientists, computer programmers. What does digital mean? Digital means something that works with digits, actually works with numbers. So if you have a digital clock, it doesn't have hands pointing to numbers to represent the time. It has just the numbers up there. And the numbers change. And if you have a digital computer, it's not going to use gears or voltages or other things to represent numbers. It's going to have actual numbers in the machine. And that is the difference between digital and analog. An analog thing is something that is analogous. They make an analogy to numbers and do the calculations that way. And we still do have analog computers out there. They're becoming more and more rare, but they do exist.
And its purpose is to present a general introduction to the subject. The computer process is a logical one and is easy to follow. It begins with the problem, which may concern virtually any subject that can be treated mathematically. Determining the path and time position for the orbiting satellite. Computing payrolls for thousands of employees. Equalizing the load in a power transmission network. Controlling airport traffic. Forecasting the weather. Or designing a missile and its system. Whatever it is, you have the problem, and you have data or information which the computer will process to arrive at a solution. To do this processing, the computer needs instructions. So you write a program, a complete, detailed list of every operation the computer must perform to solve the problem. Then, the completed program, that is the instructions, and the data, the information to work on, are both prepared for insertion in the computer by transferring them to an input medium. This may be punched cards, punched paper tape, or magnetic tape for automatic insertion. So these are things that we do not use at all anymore for an input medium to put data or information into a computer. We do not use punch cards, we do not use rolled up tape with holes in it, and we don't use magnetic tape. What do we use now? Well, we use keyboards, we use the internet, we download things from the internet, that's information that we put onto the computer. We use a USB drive, we use maybe a CD or a DVD ROM of some kind. Even those are going the way of all the earth soon enough. And after these
cards and tapes and things were used. They started using discs, but they were much different than discs we use now. Then they started using what they call floppy disks, and they had so many different kinds of those. And the first computer I ever used actually used a cassette tape, like an audio tape. And you plugged it into the cassette and you pressed play, and you had to leave the computer for like 30 minutes to wait for all the information to upload, wait for the program to upload. It took a long time. And so we've come a long way here, but it's still the same. We still have to input something into the computer. The computer has to get some information from us, whether that's us downloading something from the internet or clicking on something in Windows or typing something in, whatever it is, we put that information in.
Or a typewriter for manual inputs. The medium carries the inputs in code language acceptable to the computer. The computer first stores the program and the data, and then processes the data as directed by the program.
So that's
The
what the,
results of the computer's work are transferred to an
for the storage, that's what the memory is all about in the computer. For long-term storage, we have hard drives, and for short-term storage, we have what we call RAM memory, random access memory. Short-term memory erases every time you turn off the computer, and the hard drive stores the memory as long as you want it to be there.
output medium, such as punched cards, punched tape, or magnetic tape, that presents the data in computer language. Or the medium may be a printer that presents the output in readable form. Thus, the solution is the completion of the process that began with the problem and the data.
And of course, our output medium today, the main output medium we use in computers today is the screen, which, believe it or not, the first computers did not have. The first computers did not have any kind of screen. They did not have any kind of keyboard. And the way that you entered data in was you actually punched holes in cards, and the position of the hole that you punched in the card told the computer what that card was telling, what you wanted it to do. And you were speaking a language that was so very different from English that it was just a problem. And not only that, but each card could only carry a few holes. I mean, you have these cards that I think my dad used to write my Saturday morning jobs on the back of his leftover punch cards when he used them. And they were about 8 inches long by about 3 inches wide, so not very big. And you could fit essentially about, you couldn't even quite fit one command on a card. It was not quite good enough for that, if I remember correctly. And so a program, a very simple program, could contain a stack of hundreds of these cards. And you would put them in this machine that would read the cards, and would put this through another mechanical machine that would read the pattern of dots on each card and input that data. Somehow I had some kind of transfer method that put it into the computer memory. And then once all those got fed into the computer memory, then you could start running things and start doing things. And I'll tell you what, the computer memory of that big computer you just saw there is less than anybody's iPhone. Anybody's smartphone. Did not have a lot of computer memory. So essentially, you could go to the moon with the computer in your smartphone.
These elements are pertinent to all automatic digital computer systems. Now let us look at the functions performed by the computer. It has the ability to add, which it does by counting, to subtract, by counting in reverse, and to multiply and divide, operations that are based on addition and subtraction. These are the computer's arithmetical operations. It can also perform what are known as logical operations. It can compare one number with another. It can sort numbers into a particular order. It can find a specific number. And it can do such things as distinguish between positive and negative signs. Thus, the computer can make simple decisions or choices, but only as instructed. It operates on the basis of simplicity in the mathematical functions performed, multiplicity in the number of times these may be done, and speed that is fantastic. It is accomplished electronically by means of transistors, semiconductor diodes, and vacuum tubes. Such devices have a two-state characteristic, the ability to switch from one state to the other. Off, on, cut off, conduct, low voltage, high voltage, and so on, switching in this manner in millions of seconds, microseconds. This two-state characteristic is the foundation of electronic digital computer operation. However, these two states and the 10 digits of our decimal number system are not compatible, cannot be easily matched. Fortunately, there is a number system that is compatible. It is based on only two digits, 0 and 1. This is the binary number system, bi meaning 2. You'll hear a great deal of it in connection with digital computers. These two digits can be used to represent any number we wish. You'll find a full explanation of it in a later film. For now, let's accept the fact that a two-state device, such as a lamp, or a diode, or a transistor, can be used to count in the binary system. Off can be considered binary 0. On, binary 1. Let's add another component. Now there are more possibilities. 0, 0, 0, 1, 1, 0, and 1, 1. 3 will give us more combinations. Add more lights, and even more combinations are possible. Since the computer is one.
So at this point, I'm tempted to tell a joke. And the joke shows up on t-shirts on nerds everywhere. And the joke is there's only 10 types of people in this world, those who understand binary and those who don't. Of course, in binary, 10 or 1, 0 is not 10. It's actually 2. So the shirt says there are only 10 types of people in this world, and you're thinking binary, it should be 2. It's a great joke for nerds, in case you want to be classified as a nerd.
Language is binary. We must feed data to it in binary form. Take these binary ones. They can be represented by holes punched in a card at key locations. Unpunched locations represent binary zeros. We can use words like these as an input medium or an output medium. Special coding enables us to represent letters of the alphabet, punctuation marks, and other symbols. A single card has approximately 1,000 locations for such bits of information. Bits is an abbreviation of binary digits. The data recorded on the card are read by metal fingers or brushes that make electrical contacts through the holes, and no contacts where there are no holes. Reading may also be done by using light beams and photocells. Paper tape is a similar carrier of information. Magnetic tape, which has iron oxide coating, is still another vehicle for information. Small areas are magnetized, shown here symbolically, in one direction to represent binary 0, and in the other to represent binary 1. Thus, problem data and program instructions carried by the tape or whatever input medium is used enter the computer in the form of a binary code. The computer is part of a system that includes input and output devices. The input device is a data reader that converts the tape or card information into coded pulses of electricity, high and low voltages that represent binary ones, and binary zeros. The computer contains storage, control, and arithmetic sections. The storage section, sometimes referred to as the memory, contains elements that receive and store the problem data and the instructions. The control section directs all computer operations. Essentially, control is a timing and gating system for transferring data. It controls input, takes each instruction from storage and interprets it, sets up the arithmetic section to do the mathematical or logical operations required, releases the problem data to the arithmetic section, and routes the results to storage. When the problem has been worked out, control routes the result to the output device. This device transfers the results to an output medium, tape, cards, printed form, or visual display. This then is the general scheme of operation of an automatic digital computer, midget or giant. In subsequent films, you will get to know the special meanings of such terms as word, logic, register, clock, and, or, and flip-flop. The automatic digital computer is a remarkable tool. In its many forms and sizes, it can do almost anything, but only at man's bidding. It will never duplicate the achievements of the human mind, for the computer has no initiative, no imagination, no spirit. Yet it is opening new fields of thought and work, and new goals for the human race. Man has made many tools that have multiplied the power of his hands. Here is one that multiplies the power of his mind.
That's kind of a weird statement to end on, because all the tools that multiplied the powers of our hands allowed us to be more dexterous, which developed our brains more, which allowed us to build more tools that made us more dexterous, which developed our brains more. Every tool man has created has made us smarter and has developed our mind. Even the wheel and sliced bread. But that is a video that I really like because it does touch on the fundamentals of computing. And the fundamentals are is that we have this machine that will store information, will store instructions, and as long as you put those instructions incorrectly and that data incorrectly, it will work on that data following your instructions. And it may put it back in memory and may output it somewhere, but that's the basic idea. And in this class, we're going to be doing all of those things. So we need to understand how that works. So, back to MATLAB. Here is our input device. Our input device is going to be partially, it's our keyboard in concert with our screen, our mouse as well, and that's how we're going to get information into our computer. And MATLAB is going to be the thing that stores it for us in the memory of the computer. And so, if you do have your computer, and you do have MATLAB on it, you can go ahead and open it up. And we'll spend a few minutes here, not too long. I'm too tired and feel too bad. We'll spend a few minutes looking at some different things we can do with MATLAB. Let's see how. All right, so we've already done some addition, we've done a little subtraction, we've learned about the pause tool here, the pause function. This is what we call a function, and it is a reserved word in MATLAB. It's used by MATLAB. And let's see here. Let's just do some basic mathematics, I think. One of the things that you can do down here in the command window or up here in your editor window is you can type in a command CLC. Let's see what that does. So CLC stands for clear command. If you type in CLC and you hit enter, it clears your command window, it cleans it up, nothing in there. Notice that your workspace is still here. So that's still going. If you want to get rid of all your workspace, for example, if you want to use W for some other thing, you can just reassign it, or you can just clear your workspace as well. And if you want to clear your workspace, you go clear all, and it'll clear everything in your workspace. However, there are other options as well. And how would we figure out what those other options are? We go to help, clear, to learn what clear does. So, we can clear particular variables. If I just go clear, it removes all variables. If I go clear variables, it removes all variables again. If I go clear global, it will clear everything that MATLAB is using anywhere or has used anywhere. Most people don't need to use that very often. Clearing functions. You can also have functions over here in your workspace, which we haven't talked about yet, but functions are essentially like little programs. So you can clear those as well if you've made any functions. Clear all removes all variables, globals, functions, and MEX links. So clear all will do all those things. Clear all, when you do it at the beginning, also clears the base import list. So anything that MATLAB brought in will be cleared as well. You can clear import, you can clear classes, so you can clear different types of things. And they talk about the different things that you can clear. You can also clear individual variables. Right here, variable 1, variable 2, and so on and so forth. And they just give lots and lots of other ways that you can clear. You can clear things that begin with certain letters. You can clear things. There's lots of things that you can do. And they give you different ways. They show you all the different ways you can do that. I'm not going to go through them all. It gets kind of tedious. So if I start my session with clear all and CLC, then I start with a fresh page and a fresh workspace, nothing getting in my way, nothing bothering me. Something that often people will do is they will go to close all, because when you're working in MATLAB and you make an image, for example, it puts it in a window, and oftentimes it's in a separate window. And if you don't want those messing up your desktop, you can go close all and close them all and go back to CLC. So that is, that's using those commands clear, CLC, in, and close in the command window. If you use them in your editor in any particular place, for example, if I got to this point and I wanted answer to be just empty now, I could go ahead and put in clear, and I could do clear all, or I could clear answer or whatever, like that, and put that in. And if I go ahead and save that again, and then run it, and we'll see if I did it right. So there's my answer. It's pause. Answer first is 8, and then there's a pause. And then if I click another button, it gives me my next answer. I have to go down here and click another button. It gives me my next answer, -2. And then if I type in answer here, it doesn't give me anything because I cleared it in my previous window and I did it properly. Clear, just put clear and answer for A and S. So you can use it in either place. You can use it in your command window or in your file. I'm going to go down here and I'm going to say, I'm going to put some comments in here. I'm going to say starting real MATLAB lecture now, just so I know where that starts and I can take this keyboard. I'm starting the real MATLAB lecture. Go ahead and enter there and move on to the next one. Next line. And let's talk about arithmetic functions. So what kind of arithmetic functions can MATLAB do? Well, just about anything, it turns out. MATLAB is very powerful and very useful and very capable of doing math. in the video that we saw, they said that computers can add and they can subtract, multiply, and divide. But in truth, computers can actually only add when it comes to math. They add. When they subtract, they just add a negative number. When they multiply, they just add and add and add and add and add. And when they divide, there is also a well, you can essentially subtract, right? When you're multiplying, which is just adding a negative, adding a negative, adding a negative. So multiplication, division, subtraction, they're all just addition to a computer. But since a computer adds and adds very quickly, it can multiply very quickly and divide very quickly. And it turns out that even things like calculus are nothing more really than adding. For those of you who have taken calculus, you understand that. If you have not taken calculus, you will someday understand that. But it turns out that pretty much all mathematics is just adding, as long as you stay within the realm of arithmetic, where you're just calculating numbers, you know, the summation of numbers and the multiplication of numbers and so on and so forth. If you get into something like algebra, it gets a little harder. In algebra is not arithmetic. It's more like real math, where it's kind of like educated guesswork. And to make a MATLAB do algebra, you have to have a lot more involved. And so that's where they get into the idea of choosing things and comparing things. And that was the other thing that computers did. Computers can add, and they can compare things. They can look at whether something is on or off. Right? Yes or no? Lit or not lit. And that's what we call logic. And if you combine logic with arithmetic, you have a truly powerful machine. And that's what computers today are capable of doing, is they're capable of doing both logic and arithmetic, and doing them very quickly and very accurately, as long as you tell them to do it accurately. If your program is bad, the computer will be bad, I promise. So of course we can do addition, we can do multiplication, and multiplication is done using the little star symbol here, 5 times 6, for example, and we can put that in there. We also have division, which is done by the little /. So if we do 8 divided by 4, I'll do 8 divided by 45, why not? And that can be our division. And you can do many operations all at once. You can do 23 minus 4 divided by 67 times 8 plus 5 or whatever. But you have to remember, you have to realize that people have programmed MATLAB to understand order of operations. Okay? If the computer was just left to its own devices, it might just start at the beginning and go to the end, or it might start in the middle and move outward or whatever it would do. But somebody has programmed MATLAB to look at this problem and to make some decisions, to use some logic and say, well, I'm going to do certain things before I do other things, and we're going to have order of operations. Remember the order of operations, you do things inside of parentheses first, and then you do powers next, and then you do multiplication and division next, and then you do addition and subtraction last. And so, and there's some kind of way to remember that. I don't ever remember what it is. But anyway, MATLAB is programmed to know how to do that properly. So when you put this kind of code in, it's going to go ahead and do it properly. If you start putting parentheses in, for example, if I'm going to shift and copy that line right there. Copy it, and then I'm going to do it again. I'm going to paste it. And copy and paste is really important in MATLAB. Hopefully I'm using it right here. Nope, that's not right. Okay, so if it doesn't work on your keyboard, then just use right-click on your mouse. So if I just right-click here, I can go to copy, and I can go down here to paste. Put that in there again. If I start putting in some parentheses here, I'm going to force MATLAB to choose to do things in a certain order. And notice that little beep. It's telling me something is wrong. And what's wrong? What's wrong is I've only put in 1 parentheses, and it wants 2. And notice that when I put in that second one, it highlights the parentheses and matches things up. And that's important, because if you leave your parentheses uneven, it won't do the math right. And of course, if I want to run this, I can save it, and I can go ahead and run it. And it's going to take, whoops. Go down here and click my button so I can go through the rest of them. And if I wanted to pause in between some of these, I might just put a pause in here. And then I could go on and I'd have to save that again. And then I could run it again. But I'd have to go back down here and hit enter for that first pause, and hit enter for the second pause. And notice it's just giving me the output. It's not giving me anything else. But what if I don't want the output? What if I come back in here and I say, well, I don't want these to print out to the page, or maybe I start assigning some variables. Let's say that I'm going to say that A is going to be equal to 3, and that B is equal to 6. And then I'm going to do A times B. Why not? Let's try it out. Save this, and then I'm going to run it, and I get the beginning of the script, gives me that first part, and I have to hit the enter and get the next part, and I get the next part. And notice here that I have my A, it's in here, my B is in here, 6, 3, and 6 times 3 is equal to 18, so the answer is 18 at the end of that script. But what if I don't want it to show me what A and B are? What if I just want to know what the product of those two is? Well, what I can do is I can go up here into my script and I can put in a semicolon. If I put in a semicolon, it will stop printout to the screen. So I go ahead and save that. Now, I'm going to give you another quick tip here. If you don't want to keep hitting save and run every time, and your cursor is inside of your M file, go ahead and hit F5 on your keyboard. If you hit F5, it will save it and run it at the same time. Then you can just click down here, and you can hit enter, and you can see what happens. It doesn't print A and B to the screen. It just prints the answer, and you're good to go. We can also do things like sign, but the function of the sign function requires that you put an argument in it of some kind, and you have to put it inside of parentheses. And that argument is going to be interpreted as an angle measured in radians. Now, if you've never used radians before, just think of them this way. There are 360 degrees of angle in a full circle. And there are 2 pi radians of degrees, 2 pi as in 2 times 3.14, radians of degrees in a circle. Excuse me, I have to blow my nose. Okay, so essentially, 360 degrees and 2 pi radians are the same amount of angle. So the sine of 360 degrees is 0, because you come right back around to the starting point on the unit circle. And the sine of 2 pi, I'm going to do 2 times, you have to put multiplier between it, you can't just say 2 pi. 2 times pi is going to be my full circle in radians, in angles measured in radians. Go ahead and save and run that again, and I start again at the beginning, and I'm going to hit enter and go through here. And it looks like my answer for the sine of 2 pi, they're saying it's negative 2.4493 times e to the minus 16. What is that? That's essentially 0, isn't it? It's a very, very small number. And if I do sine of 2 times pi here, I put in a capital pi, it doesn't recognize it. And here it's actually going to give me a suggestion. Did you mean sine 2 times little pi? And it puts it right in the command room for you. Excuse me. It's almost time for me to be done, so that you can check it again. Why does MATLAB do this? Well, MATLAB is a computer. It only knows what you tell it. And is pi an exact number? No. Pi is not an exact number. There is no exactness to it. Okay, exact is a wrong question. Do we know pi to its exactness? It cannot be written down to its exactness because it is a ratio, and part of that ratio is unknown, part of it is measured. So if you have a circle that is exactly 1 meter across, and you divide the circumference of that circle, which you would have to measure to some degree, you would have it imperfect, and divide it by the half of the 1, then you would get pi. Well, you divide by half, essentially. Well, the problem with that is the measuring of the circumference. Even if your radius is exactly 1, or if your diameter is exactly, or whatever. Even if you have that exact, the measurement of the other one will not be exact. And so we can only put pi into MATLAB. We can only enter it into a certain number of digits and will not be exact. However, if I take the sign of 0, it knows that. 0 is an exact number. It can deal with that. So it knows how to deal with that. It can also, well, anyway, and you can adjust the way that outputs numbers. You can actually have it round to certain values and not give all so many digits, because in this case, right now, it's set at its standard settings. And we'll learn more about how to set up MATLAB in different ways as we move forward. I was going to do that actually today, but I'm both getting tired and running out of time, so I probably will not. But I will go on to do the very next thing, which is to introduce you to what MATLAB is really all about. MATLAB is the conjunction of two words, matrix and laboratory. And the whole purpose of MATLAB is to do not just one calculation fast, but to do an entire array of calculations fast, a huge amount of calculations. And all of those calculations can be the same calculation with different numbers, or it can be different calculations with the same numbers, or it can be other things like this. But it's designed to do huge numbers of calculations at the same time, all at once. And in that way, it is an extremely useful program. Not many programs can do that easily and quickly. MATLAB is one of the few, and that's why it's very useful. So let's take, for example, let's calculate, let's say that we have 96,000 employees in our company, and they all have different paychecks for different hours that they worked. Well, we could easily do that in MATLAB, and the way that we would do it is by creating an array. I'm going to create my array down here, and then I'm going to paste it in my M file later. Well, I'll create it up here and then paste it in the command window. So let's go down here, and I'm going to say about arrays. We're going to talk about arrays in general. And I might go back after I've done some programming and look at this and think, what was I doing up here? So maybe I want to go up here and put in some comments. It's a really good idea. I'm going to say about order of operations. Now this stuff is pretty self-explanatory, but it's a good habit to get into, to get into making notes in your programming and putting space in your programming. So I'm going to go ahead and put a pause in here too, just so that it separates this out from other things. And I'm going to create an array. And most programmers will either put their comments in line with their code or to the right of their code, or a little bit of both. Very few programmers put their comments to the left of code. Seems like it would work out fairly well, but not many people do it. I think it's because they like their code to line up on the left hash really nicely. But I do a little bit of both, some out to the right, some in line. It's just a matter of preference, I think. Right here, I'm going to say, I'm going to put something in line here. I'm going to put create an array, or a matrix is another word for an array, of hours worked. And it's really easy to create an array in MATLAB. So hours worked, I'm going to call it hours. I may even call it hours worked. It's very important to choose your variables in MATLAB descriptively so that you don't have to guess what they mean. So if they actually have a meaning, if they correspond to something in the real world, call them that. Just don't make them too long, and don't make them too complicated, and don't make them something that MATLAB's not going to use. So, not going to like. So you have hours worked. And another thing that a lot of people do is they like to put a space between their variables and their equal signs. And it's just a style thing, but it separates things out a little bit, and separation is always nice when you're programming. MATLAB doesn't know the difference. It just skips over spaces. So you got hours worked. Well, it only skips over spaces in between words and functions. If you type in pause with spaces in between them, letters, I don't think it'll work. But anyway, hours worked is going to be my array, and I'm going to go ahead and set it up. And there's a couple of different ways we can do it. I'm going to use a square bracket. I'm going to put in some numbers, 23, and I put in a space, 45. So in between numbers, spaces do something, especially if you put them in an array like the square brackets. 12, 56, 33, 13, 98, and 67. 670, why not? And I'm going to close my array by putting a square bracket on the other end. Now what I'm going to do, instead of running this whole file over and over again, I'm just going to copy that really quick. I'm going to put it down here in my command window. Paste it down here. And it's just going to run it. So hours worked is 23, 45, 12, 56, 33, 13, 98, 670. Now it knows that the variable hours worked is this list of numbers. They're all separate numbers, and it knows that. And guess what? If these people are making $8.50 an hour, I can take hours worked, hours or underscore worked, and I can multiply by, what did I say, 875? I don't remember. Times 875. And I can give it a name. Like we can call this one pay. Whoops. What the heck was that? Anyway. And in this case, it's giving us pay in scientific notation. 1.0 times 10 to the 3 times 0.21201. Does anyone know what that number is? This number is going to be $201.30. And this one's going to be $393.70. This guy here that worked hundreds of hours is $5,862. So all those numbers are multiplied by this multiplier up here. And you can change that. And we change it by doing format. And how do we use format? Oh, yeah. How do we use format? Well, we're going to put in help format. So let's find out what we can do. Help format. We can have short. We can have, let's see, here we go. Here are all the ones. We can have short. We can have long. So up to 5 digits or 15 digits with the long. Short E and long E are for what we call floating point formats, and we'll not get into that right now. And short G, long G is another one like that. But we have short engineering G. It's actually an engineering format that is used a lot in engineering, but not many other places. We can also do hexadecimal. We always print off plus and minuses for every number so that we know if it's a positive or negative number. We can do a bank format. Hey, that sounds good for our problem. So let's go to our command window, and let's go to Format, Bank. Let's hit Enter, and then let's look at our last, let's actually not, we don't even have to do that. We're in Format Bank, and we can come over here and click on Pay. If we click on Pay, and we can actually just pull it in here, and hit Enter, right? I think if you double click on Pay, it gives you the numbers too. Yeah, so if I double click on Pay, it opens it up in my editor, and you can see those numbers in that format. Brings it up in the editor window as a file. But we can use this to create, and you can see here that these are different columns. They're calling them columns. And that suggests that maybe you could have rows and columns. We put in our hours worked here, just one after the other with spaces in them. But we could maybe get multiple rows. Well, how do we do that? Well, we can certainly do that. We'll call it sample matrix. You need to put an underscore in there because matrix is something MATLAB knows about, has a use for. So my sample matrix is going to equal some set of numbers. And then if I put in a colon or a, let's see, is it a semicolon or colon? I think it's colon. So that's my first column essentially, and then this colon is going to delineate the next column. And then I put in another colon, and I put in my next column. And I can do that as long as I want. Put in 34, and 1, and 0. And if I copy that and put it in my command window and see what happens. Now let's see what happens. Let's paste this. So now, I've got a sample matrix here. Let's see, did I do it right? If I open it up, it should show me if I did it right. Sample matrix. No, I didn't do it right. We just put them all in a row, so we must have done something wrong. Well, how do we fix that? We try something else. Or we can look it up. We can also look it up in help. I'm not going to look it up because I'm just going to guess at it. But it's always a good idea to look it up. We put in a semicolon because I think it is a semicolon. If it's not that, it's a comma. Let's, oops. What just happened? Oh, I need to go to my editor and undo some things here. Where are my undo arrows? There's my undo arrow. We go up here to undo, it undoes that, undoes that. And I'll undo one more thing. Okay, so that's right. Copy, this keyboard is giving me grief. Paste that. So now it's put it into columns and rows. So it turns out that between the different columns, you have to put in semicolons, not colons. I got that wrong. That happens quite often when you're programming. You forget things and you just have to figure them out. And if you wanted to ask, just put in help and matrix. Help array or whatever. So you can do simple arithmetic, and you can even do very complex mathematics with matrices. At this point, I'm going to close my discussion of MATLAB because I'm tired and sick, and we're almost done anyway with time. So what I want you to do for tonight is I will go ahead and get this video uploaded as soon as I'm done recording it and saving it and all that stuff. I'll get it uploaded. So if you didn't have MATLAB open in front of you today, you can go and watch this video, and you can fast forward it until the times I type things in, and then you can type your things in and learn some things about MATLAB. And then I want you to go to the assignment, which I will also finish up. I think that I'm going to put maybe just one more problem in it, maybe a couple more, but. And then you can start on the homework. And you'll notice in the homework that I've asked you to enter in several different MATLAB M files. So each MATLAB M file for each problem will be a different one. And there is that video to watch in MATLAB as well on how to create an M file. I want you to watch that and follow along with those operations that we're being done there. And that's all I have for you today. Are there any questions for me before we end up here? Any questions, McCook or Luke County?
I think I'm all right.
What's that?
For the passwords on Blackboard,
Yes.
I just message you or send you an email, and you can get me the.
Yes, you can send me an email, and I will point you in the right direction to the person who can give you that information. I can't remember who it is now. It used to be somebody else, and now they've got some other person doing it. But I'll figure out who it is, and I'll point you on to the right person, and we'll get you guys started. And if I'm feeling any better tonight, I will get all this done very quickly. If not, it might take me a little while as I try to cure my sickness. And I promise I'm not always this boring. Just most of the time. All right, any other questions? We good to go?
Is your telephone, is that your cell phone? Is it like, will you be
It is
available
not.
all times a day?
It is not a cell phone. Let's see if I can switch this back to, let's see, no, not stop share. Yeah, I stopped the share and it takes me back to video. Here you go. So, it's not a cell phone, it's my office phone, but it does send messages directly to my email, and I'm checking my email regularly throughout the day. So usually till about 9 or 10 at night. So, all right, you guys know what you got to do?
Yeah.
All right, well, you guys have a good week. If you have any questions, please email me. Any concerns, please email me. Anything, please email me, and I will help you out with whatever we need help with. And you guys have a good week.
You too.